This is section 6.6, DeMoivre's Theorem and nth roots. We're going to talk about the complex plane, polar form of complex numbers, multiplication and division of complex numbers, powers of complex numbers, and roots of complex numbers. Okay, so graphing complex numbers on a plane. So you can see that what we traditionally think of as the x-axis, that's our real axis, and the y-axis would be our imaginary axis. So if we're plotting the point 2 plus 3i, you go over 2 in the real direction and then up to 3i in the imaginary direction. So the absolute value, or the modulus of a complex number, is basically you're finding the distance, and we're going to look at a picture where it shows that. So you're taking the square root of a squared plus b squared. So that's the absolute value. So you can kind of see why if we make it into a triangle on this one. So we have, so our x distance is r times the cosine of theta, and our y distance is r times sine of theta, and our length here would be r. Okay, so polar form of a complex number, and that's coming from what we just looked at, and we have our angle here. So polar form is r times cosine of theta plus I sine of theta. And again, if you think back to the complex plane, that's because what we traditionally think of as our y direction, or sine, that's our imaginary part. Okay, so to find r is the square root of a squared plus b squared. And then we're going to use this idea, we know tangent of theta is going to be b over a, so that's going to help us find theta when we're trying to find that to put it into polar form, and theta is the argument of z. Okay, so example 1, we're going to find the polar form with theta being between 0 and 2 pi for the complex number 1 plus square root of 3i. So the first thing that we need to find is we need to find r. So we're going to take the square root of 1 squared plus the square root of 3 squared, which gives us 1 plus 3, which is 4, so b square root of 4, which is 2. Then we need to find theta. So we think of, so tangent of theta is the square root of 3 over 1. And so we're thinking of, so when we try to go from this step back to an angle, what I think of is typically, remember, we cancel the denominators to simplify. So if I add a denominator of 2 back in, you're finding out what angle has a y value of square root of 3 over 2 and an x value of 1/2. And so that would be pi over 3. So theta would be pi over 3. Okay, so that means that polar form of this would be 2 times cosine of pi over 3 plus I sine of pi over 3. So that would be polar form of 1 plus square root of 3i. That's an I. Okay. Okay. Product and quotient of complex numbers. So you can see, so if we have one complex number and two complex numbers, if you want to multiply them, you'll end up with r1 times r2 times the cosine of the sum of the angles plus I sine of the sum of the angles. Where division, you're subtracting the angles, that's the difference. And you're also dividing the r values. Okay, so here's an example. We're going to multiply complex numbers. So we have this number and this number. Those are our two numbers. Okay, so to find the multiplication, so we're going to do z1 times z2. So we're going to take the two r's multiplied, so 4 times the square root of 2, and then it's going to be cosine of pi over 4 plus pi over 6 plus I sine of pi over 4 plus pi over 6. I should use brackets. Okay, so then we get 4 square root of 2 times cosine of, so if I add pi over 4 plus pi over 6, get common denominators, I get 5 pi over 12. Oops. Plus I times the sine of 5 pi over 12. So then if you're getting a value and you're putting it back into not polar form, then we can just multiply. So we can take 4 times the square root of 2 times, so if I put cosine of 5 pi over 12 and I make sure my calculator is set to radian mode because that's what my angle is in, I get 0.259 plus I times, same thing, if I type in sine of 5 pi over 12 in radian mode, I would get 0.966. So then I can take this and distribute. So I end up with about 1.464 plus 5.464 I. Okay. So now we're going to talk about raising a complex number to a power. So this is a visual of what geometric interpretation of what z squared would look like. So you can see here is your original complex number, and here's theta, and then to find z squared, you're going to use 2 theta, and this length is r squared. So DeMoivre's theorem, okay, practice saying that correctly, okay, is, so if we have our complex number here, we take, so to whatever power it's going to be, so n power is going to be r cosine of theta plus I sine of theta raised to that power, and then it would be r to the n times cosine of n theta plus I sine of n theta. Okay, so let's practice that. So we're going to find this complex number raised to the 4th power. So the first thing that I'm going to do is I am going to find theta. So I'm going to use tangent of theta, remember, is going to be our b value over our a value. So it's going to be -1/2 over negative square root of 3 over 2. So we're thinking, okay, where do we have a y that's -1/2 and an x that's negative square root of 3 over 2? So we're going to be in that 3rd quadrant, and so this would be, theta would be 7 pi over 6. Okay, next we need to find r. So r is going to be the square root of negative square root of 3 over 2 squared plus -1/2 squared. So if we simplify that, r is just 1. So z would be 1 times cosine of 7 pi over 6 plus I times sine of 7 pi over 6. Okay, so now we want to find z to the 4th power. So that would be 1 to the 4th power times cosine of 4 times 7 pi over 6 plus I times the sine of 4 times 7 pi over 6. Okay, so that would be 1, which we don't need to really write anymore. So this would be cosine of 14 pi over 3 plus I sine of 14 pi over 3. So then what we can think about, 14 pi over 3 is bigger than 2 pi, so we could find the coterminal angle with 14 pi over 3. So if I subtract 2 pi twice, I will get 2 pi over 3. So that means that this is the same as saying cosine of 2 pi over 3 plus I times sine of 2 pi over 3. And then we can actually get those values. So z to the 4th power would be cosine of 2 pi over 3 is negative 1/2. And then sine of 2 pi over 3 would be negative square root of 3 over 2. Sorry. It'd be, so we'd have square root of 3 over 2. We can put the I in there. So that would be our solution. Okay, so the last thing is finding the nth root of a complex number. So if we have, so a complex number, so written as a plus bi, is the nth root of z if v to the n equals z. So we're going to jump into an example of this. So it says, so if we have in polar coordinates, we have z equals r times cosine of theta plus I sine of theta, then the n distinct complex numbers, and this looks super complicated here, but we're going to see how this works in a minute, where k equals 0, 1, 2, all the way up to n minus 1, or the n roots of z. Okay, so let's look at how this works. So we're going to find the cube roots of 1. So cube roots, so that means that we're looking for k equals 0, 1, and 2. So we can write this as in complex form here. So we have 1 plus 0i, because 1 does not have an imaginary part. So if we write that in polar form, it'd be cosine of 0 plus I sine of 0. Okay, so we're going to use that formula from the previous slide. So we're going to say cosine of 0 plus 2 pi k over 3 plus I times the sine of 0 plus 2 pi k over 3. And we're going to use 0, 1, and 2. So our first one would be cosine of, so if we put 0 in for k, that's just going to cancel out and be 0, plus I times the sine of 0, so that's going to equal 1. And we know that. We know 1 is a cube root of 1. Okay, and then our complex roots, so if I plug 1 in for k, that would be 2 pi over 3, so it would be cosine of 2 pi over 3, plus I sine of 2 pi over 3. And so we would get negative 1/2 plus the square root of 3 over 2. And I just realized I think I made a mistake. This right here, sine of 2 pi over 3, that should be a plus. Because cosine would be negative, 2 pi over 3 is in the second quadrant. So cosine would be negative, sine would be positive, so that should have been a plus. Okay, just had to correct that really quick. Okay, so then we find the third root by doing cosine of, so if I plug 2 in for k, that's going to end up being 4 pi over 3 plus I times sine of 4 pi over 3. So that would be negative 1/2 minus square root of 3 over 2. I. Okay, so that's finding the cube roots. So there's a lot of information in this section, so please let me know if you have questions about